Good morning and good afternoon. My name is Ashish. So I'm going to discuss about the recently the paper has happened for the AP Physics Mechanics 2026. The first FRQ that I'm going to discuss it that they uploaded recently only. So let's go deep into that. Thank you. So this is 2026 AP Physics Mechanics free response question. We are going to be start with the first FRQ. So this is the version J. I have it. The question number one. So in this question, what they mentioned is a box of the mass m slide on the right of the horizontal surface. So there is a box m, capital M, that is sliding to the right side, and a small m cube. So this is a cube that is placed over there. Is also the m mass is inside the box, and the cube is against the right wall and the box the above the bottom of the box. It is not touching the ground. They need to say that. As in the figure shown, the coefficient of the static and the kinetic friction between the cubes and the walls of the box of the U S and the UK is respectively that equivalent. And they mentioned that the static friction force, so the coefficient of the static friction force is more than the kinetic one. So the mu S is greater than the mu K. Now, the speed of the box is decreasing as the result of the resistance force is exerted on the box. So there is a one force, a resistance force that is acting in the opposite direction to the motion. That is how the resistance force will work. And the resistance force Fr is modeled by the Fr. So that is the resistance force Fr minus BB, where the B is the some constant and the V is the velocity of the block, and the friction force between the box and the horizontal surface is negligible. So this friction force, they ignored that one. There is no friction force. So there is an external force that is acting upon that is the only the resistance force or due to the air. You can say like this air resistance that is and that is directly proportional to the V speed of the block will be. So now consider the motion of the block. Okay. At the t is equal to 0, the box and the cube system slide to the right with the velocity of v naught. So the initial velocity is the v naught if that is given. For the time is from 0 to t critical. The cube remain in the contact. So at this up to the time t is equal to 0 to t critical. So I'm going to call it critical time. Up to that time, they are in the contact with each other. After that, it's going to be slide down and will fall down. So, in the contact with the wall at a constant height above the bottom of the box. So it is no longer in the any kind of the motion also in that duration of the time. So it means that the static friction force is acting between this time duration. Now at t is equal to t, see the cube begin to slide down along the wall of the box. So they have mentioned that one. So if I quickly summarize that, they have mentioned few things here. Critical. So there is no relative motion. So no relative motion between the block and cube. So there is no relative motion over there between the block and that. So we are going to be used in this. That should be clear that the static friction force we are going to be using. So as you have after that critical, after T is equal to T critical, the block start moving. It's like there is a relative motion. In that, there is a relative motion. A relative motion is happening. Kinetic friction force I'm going to use. Now, first part of the question. The magnitude of the normal force exerted on the cube of the ball. Now determine the expression for the magnitude of the acceleration of the cube. Express your answer in the term of m, fn, and the physical constant. So if I had to make a free body diagram of this block, so there is a only the force that is acting upon that is normal force. That is the normal force that is acting upon that. That is the wall of the box that is applying to the side. And mg force is always vertically downward. And there is a friction force that is going to be acted upward. So these are the uh, forces that are acting. So let me show it again here. So mg force is downward, friction force is acting it upward, and Fn the normal force that is acting it down. So there is only the one force that is acting in the horizontal direction, that is the Fn. So as we know that according to the second Newton law, so the net force that is acting on the any body that is equal to the mass time acceleration. So we had to be determine the expression for the acceleration for the cube of that. So now net force is Fn is equal to m is equal to a, and so a is equal to Fn by m. And by the way, this direction, if you want to take it negative, so you can take it negative this one, but the normal force is also acting in the same direction, so the negative sign will cancel out. So you do not have to be worried about that, by the way. So this is the normal force. The normal force is Fn divided by m. So this is the acceleration expression that is come out to be. So that is the first part of that. Then we have the second part. Derive an expression for the Fn as the function of the time from the t is equal to 0 until the immediately before the cube reaches to the bottom of the ground. Express in the term of m, v, v, t, and the physical constant appropriately. Begin the derivation from the fundamental physics principle and write the equation. So the point is here is, so we had to be derive the expression for the normal force as the time is passing. That is immediately before it is going to be touched that, or immediately before it is start sliding that. So basically, it is not in the motion. Remember it in that duration. It is not in the motion. We had to be determine the normal force, how the normal force is changing. It is going to be. So the tricky point is here is, so in this part of the question is, this is the B part. This is the B part of the question that I'm solving. Now the thing is, now we had to be determine the how the normal force value that is changing on that. It's tricky to understand immediately. So it is going to be might be just challenging to understand that how they are saying that it is the time function. So as the time will change, the how the normal force is changing, we had to be determine the expression for that. Okay, so we had to be find out the normal force. If you think it directly, it's might be challenging. So how you can get the normal force directly. So to determine that, what we had to be consider, first step is that we had to do is we had to be take the box and the cube as a system. As a system, we had to be take a combined system. So and in the combined system, there is an external force that is acting. The external force that is minus VB, that they already given the expression for that. So if we take as a system, as a combined system, so the net force that is acting on the system, net force that is acting on the system, that is the m total into acceleration, correct? Acceleration of the system. So there is an external force that is acting only the minus BB, that is resulting in the deceleration of the system will be. So first, let me write it minus the force action force is minus BB is equal to net mass, total mass of the combined system, that is the 2m, m and the m. So that is acceleration. So, and because then what I can do is this is BV is equal to 2m. Acceleration can be written as a dv by dt because we had to be, as the time is passing, the velocity expression is changing. Okay, so now let's do the rearrangement. And if you do the rearrangement, you will get basically, I'm taking the dt to the other side. So dv. So v I'm bringing to the other side, dv by minus v by into dt. Now integrating on the both the side to find out the v value. So if I'm going to integrate, this is coming out to be the, let me put the integration sign, dv by, if t is equal to 0, the velocity is v given. So if the time is equal to, when the time is t, so let's take up to the t, the velocity is v. Let's do the integration. So this is a constant, so it is going to become outside. T 0 to t is equal to, this is ln of v, upper limit minus lower limit. This is minus v by 2 and t is equal to ln of v minus ln of v. Applying the ln property, the properties, basically you can write up this uh, and minus v by 2 and t, and then you can write it the taking the ln to the both the, so you can change it to the exponent. So v by v now, you can write it as e power v by 2 m into t. So till now, I think that is clear to you. So this is the thing that is going to be come out v. Now, so the v is equal to v now, e power minus v by 2m. So this is the thing that is going to become. So this is the velocity expression that is going to become. Let me do again the differentiation to find out the acceleration. So if I'm going to find out the acceleration, I'm going to differentiate it again. So this is as a constant. So e power that is going to be remain as it is. That is not going to be changed. According to the chain rule, we had to be differentiate this function as again. So minus b by 2 into t. So minus bv1 by 2m and e power minus b by 2m into t. So this is the acceleration. And from the above expression, the Fn, the acceleration Fn, because we had to be ultimately find out the Fn that is changing with respect to the time. So Fn is equal to mass time acceleration. To find out the Fn, that is mass time acceleration. So if I put the value of the acceleration, this is going to come out to be, and the M got cancel out. So this is actually that is capital M. So the M get cancel out. So the Fn negative sign just tell the direction of the forces. So now let me cancel out this one. So and then it is ultimately come out to be V we know by 2 e power minus v t by 2. So this is actually the normal force come out to be. This is the final expression for the normal force that is going to be come out. So this is the expression that is going to become out only. So please go through that and check any other mistake if it is happened. In the next part of the question on the axis, as shown in the figure below, sketch a graph of the magnitude of the F friction force or the magnitude of the friction force exerted on the cube on the pole of the box as a function of the time and from the t is equal to 0 until immediately before the cube reaches to the bottom of the box. So basically the thing is up to the time critical. So the it is stick together. So it is do not have any kind of the relative motion as we discussed. There is no relative motion. So if there is no relative motion, it means that the mg force is balanced by the friction force. So friction force is actually not changing during that. So if the friction force is equal to the mg force, it means so up to this, it is not changing. So it is a straight line that I have to draw, and that is the mg because that is the balance. The mg force is balanced by the friction force that is acting it upward. Then as it will start moving, so normal force is going to be changed. So this is the for the static. At it start moving, we had to be use the dynamic friction or the kinetic friction. So and as you know that the mu s is greater than or the mu k, the mu k is coefficient of the kinetic is lesser than that. So actually it will start from here. The graph is gradually the friction force decreases that and it will exponentially decay. It is exponentially going to be decay. So this is because the normal force, if you see the normal force value, that is actually that is decreasing exponentially, that is decreasing at the normal force value will decrease. So the friction force is also going to be exponentially going to be decay. Next part of the question, the P part. Drive an expression for the T critical in the term of mass, B, and the mu, and the physical constant as the appropriate beginning of the derivation. So the point is, we had to be find out critical. So at the critical, as you know, that it is static friction force we had to use. That is the maximum static friction force that is acting right now. So, and if I had to draw the free body diagram again, so this is mg force that is acting on that one and there is a friction force that is the maximum static friction force at the critical point that is acting. Um, so actually, so because it is balanced, so the maximum friction force that is acting, so actually they are writing like this: maximum friction force is equal to the mg force. So you can plug in the values of the that you find it out. The friction force is the static friction force and the normal force at the when the time is equal to critical, correct? So when the time is critical, you already find out the function of the normal force before. This one that is equal to mg. Now we will multiply to e power is minus b critical. I am writing c only for the critical divided by 2 is equal to mg. Now what I had to do is I had to find out critical. So I had to take the mu value to the other side and m equals to the other side. This is actually the expression I want to be. Now we have the let's change into the element. Now you can use the element property. Or you can simply use the element property. This negative sign, you can take the negative sign to the other side. So actually, you can write it this. you can take as a power of this. If you take the power of this, then you can do the reciprocal of that. So the critical value that is going to be time critical value that is going to become be this ln of mu s to the v. And so this is the actually the expression turned out to be. So this is the expression that is going to become out to be. Please let me know if you have still any of the doubt is left here, something you need the more explanation of the any of the part. So I will continue with this sequence of the series are of the questions are. Please subscribe the channel. It's free for you. It's very valuable for us so that the YouTube can become more happy and this can share this content to the more students that can help to the more students. Thank you. Have a good day.